All right, here's 9.4, angle relationships in circles. Mainly what I want to talk about today is the concept of being inside a circle, on a circle, or outside of a circle. All right, now notice these angles here that we're talking about, they are inside of the circle, but more specifically, they're on the circle. And when we have an angle that's on the circle, that means that we're going to cut the angle in half or double it to get the arc. And we're going to talk about different scenarios where if I have angles intersecting inside the circle or outside the circle, the rules follow when we're doing those. All right, so we have intersecting lines. That happens when lines cross or when they touch once. Okay. We can also have intersecting lines and circles. We can have them in a lot of different variety of constructions. But when two lines intersect the circle, it's where they touch the circle. So we can have them tangential, where they touch once. We can have them be secant lines, where they touch twice. And we can have all sorts of different angles and arcs covered by these types of intersecting lines. So like here we have this arc here is an intercepted arc. Here's an intercepted arc. This part and this part. We've got lots of different arcs and angles to look at. Okay, so remember we talked about outside, inside, or on the circle. If we have two tangent lines that intersect outside the circle, here's our angle, and here's the tangent points. We always have a big arc and a small arc. That's how we refer to them, so that we can talk about how to find the measure of the angle or the measures of the arcs. So same thing when we have a secant and a tangent. On your cheat sheet, let me show you what your cheat sheet looks like for the test. You're going to have this as the helper. You're going to have tangent and a chord. It's going to label what the lines are. So here's a tangent and a chord. Here's two chords, secant and tangent, and then two tangents. Regardless of the segments that are creating the angles and the arcs, you're always going to have a big arc and a small arc. Big intercepted, small intercepted. And here with two secants, you still have the big arc and the small arc. All right, so the formula for an angle outside of the circle, that's how I would refer to it, as the outside, is you always take the big arc, subtract the small arc, and divide by 2. So here, big arc minus small arc, divide by 2. That gives me my angle. Big arc minus small arc, divide by 2 gives me the angle. Same, big arc, small arc, divide by 2 gives me the angle. Now we can use this. If I know the angle and one of the arcs, I can find the other arc. Okay, again, here's on your cheat sheet. The outside angle. Outside means subtract. Remember, if you're outside the circle, then you have to subtract. Doesn't matter what the situation is. You're going to take big arc minus small arc and divide by 2. So on your example 9.1 in your notes, we're going to draw two tangent lines real quick, and then we're going to label the angle and the arc. Okay, A, B. A is the big arc, B is the small arc, X is the angle, and we're going to write out the equation. Angle X equals A minus B over 2. Okay, we're going to do the same thing with a tangent line and a secant line. Label it as A, B, and X. Then you're going to write down the equation. You can pause the video whenever you need to make sure you're caught up on the notes, because we're going to go fast. So now you're going to do the same thing with secant lines. Secant, label one A, label one B, label the angle X, write the equation. So I want you to actually go through the process of physically writing the equations so you're not just relying on the cheat sheet, so you actually can help you memorize it better and know how to use it. And now we're on the inside of the circle, and when we're on the inside of the circle, the rules change. Notice here we have two chords. They're inside the circle. Notice how it says plus right there. Okay, so when we're outside the circle, we subtract and then divide by 2. When we're inside, we add and then divide by 2. And when we're on the circle, like it is here or here, we just simply divide by 2. No need to add or subtract. So outside subtract, inside add, on just divide by 2. Okay. Oh, looks like I gotta go. Yeah. Okay. So inside we have to add them together. We draw two chords. We notice we have the big arc and the small arc. We're still going to add them together and label them properly. I write our equation. I like this because no matter where I move them, it's big arc, small arc, divide by 2. Two intersection lines on the circle. Remember we already talked about how when we're on the circle, we just straight up divide by 2. Tangent and chord, it's on the circle. A divide by 2 or B times by 2. Depends. From arc to angle, we divide, and from angle to arc, we times. It's the same with the inscribed angle. The same exact process. Okay? And don't get confused, like one side's different than the other. It's the same process, only here we know the arc, so we divide by 2. Here we know the angle, so we times by 2. So if we draw a tangent and a chord, and we label the big arc A and the small arc B. Oh, I would do it differently, but all right. So when you know the measure of the arc, if we know this measure, we know the angle is half as much. And when we know the angle is, say, B, then we know that the arc is twice as much. We kind of already talked about that. This is example 9.25. Pause the video if you need to fill it in correctly. All right, so what type of lines or line segments are involved in this problem? This is where it's going to help you with the cheat sheet. Notice how on the cheat sheet it says tangent and chord, 2 chords, 2 secants. It kind of helps you if you can identify the type of lines in the problem. Here we have a tangent and a chord. So my cheat sheet is going to tell me to look up tangent and chord. Or you could notice, look, the angle that we're talking about is on the circle. So we don't want this outside arc. We don't want XCY. We want the XY chord, our arc. And so we have to subtract it from 360 to get 100, and then follow the equation to divide by 2, and we find out that the angle is 50. Okay. That should be enough for you to work on problems 1 through 6 and 17 through 25. Got plenty of time to work on it. Pause the video if you want to, but I'm going to go on with notes. All right, now we talked about when we have 2 chords. The measure of the angle is the average of the measure of the 2 arcs. You don't need to know it's the average, but it is. You just take small arc and big arc, add them together, and divide by 2. That means it's an average. Okay, so let's start labeling our diagram. If PQ is 45 degrees, that's that arc, and that arc, angle 1 is we're going to take the 2 arcs and add them together, and then divide by 2. So we take the 2 chords, we find the 2 chords on our cheat sheet, add them together, divide by 2. There it is. So the measure of angle 1, or in this case angle X, is 60 degrees. Okay, mark the diagram. Example 9.28, for those of you who didn't notice. The question actually asks you to find the measure of arc A. Well, I know the angle, and I know one of the arcs. So I'm going to look for the 2-chord equation. Measure of angle X equals A plus B over 2. So I pushed it in. I know that A is unknown, B is 80, and the measure of angle X is 55. Now I just have to solve for it. I multiply by 2 to both sides. I subtract 80 over, and I get arc A is 30. That's how we would do it if we don't know one of the arcs, and we do know the angle. We can work backwards and solve for the missing arc. That'll help you with 7 through 10 and 26 through 32. Again, pause the video if you want to work on it. I'm going to go on with those. All right, now we're going to look at what happens when we're on the outside. We mark the diagram with the information given. We determine the formula to use. Look like here I have 2 secants. I'd look at the 2 secant situation, and I would do minus little over 2. 100 minus 40 over 2 gives me 60 over 2 gives me 30. So angle X equals 30. Okay, mark the diagram with the information given from the problem. Now it looks like we're going to determine the formula to use. I see this as a tangent secant situation. So look at the tangent secant rule, or you could just simply say the angle is outside the circle, so it's big minus little. Either way you want to do it. We're going to start substituting information in. A doesn't change, X is 65, B is 70, so I start plugging that into where it goes, And now I multiply both sides by 2. I add 70 over, and I say arc A is 200 degrees. And we're done. Okay, so we mark the diagram with the information given in the problem. I don't know arc B. I notice this is 2 tangents. Okay. So I also don't know my x. So to find b, I'm going to subtract the 240 and say b is 120. I plug it in. Remember how the full circle has to be 360. If this one's 240, then the other side has to be 120 to make up the full 360. Okay. Now that I have 2 tangents, now I can start plugging in the information. 40 minus 120 gives me 120. Divided by 2 gives me 60. X equals 60. Okay. That should help you with 11 through 14 and 27 through 34. There is some information that you might want to have on 9-4. 15 and 16 are going to be extra credit. They're sweet problems, but definitely extra credit. And the rest of them should be fairly quick and very solvable. Okay. So, back to the notes. All right. This is for no purpose other than the fact that it's awesome. This is kind of like those 2 problems that I made extra credit, okay? Just so you can see how cool this is. This is a really complex problem going on here. But if we can isolate just the pieces that we want to look at, we can find each one. So if you'd like to work on your own, you can, but I'm just going to go through it. So W right here. If I just isolate W, I can see that's a central angle covering the arc of 80. Therefore, angle W is 80 degrees. Now I can isolate other pieces of information here. Angle V, that's an outside angle. Therefore, I got to take big minus little divided by 2. I take 80 minus 60 gives me 20, divided by 2 gives me 10. So angle Z is 10 degrees. So I just got to keep isolating pieces of information that's important to me. If I look at V, well, that's an inside angle. Inside angles are added together. So we take 80 plus 60 and divide by 2 gives me 70. So angle V is 70. Now I notice that with angle 70 and Y, that forms a straight line. That means that Y has to be 180 minus 70 is 110. Again, that's a linear pair. Now we look at angle X over here, and we've got a couple different options for how to solve. We could simply add up all of the different arcs, or we could notice it's an inside angle with 110 and 70. If we use this method, then we have to start plugging in 110 where it goes, and 70 where it goes, and X where it goes. Now we multiply both sides by 2, subtract 70 over, and we notice that arc X is 150 degrees. Now notice how 150 plus 60 plus 70 plus 80 adds up to be 360. So we didn't necessarily have to go about it that route, but we could have. But either way, we just solved all of those angles. All right, now this one is another one that's extra credit, or just like the extra credit question. But it's a pretty impressive concept. You just isolate each piece. Central angle, therefore H is 20. Okay, we look here and we say we've got intersecting chords. We've got the center of the circle there. We're on a diameter. That gives us a semicircle of 180. Therefore, N is 180 minus 80. And this is going to be 180 minus 50 minus 20. So Q is 110. That gives us all those pieces. Here we've got intersecting chords, so we add them together and divide by 2. Gives me 755, looks like. Okay. So I'm just flying through this, isolating each piece that I know. So I've got an outside angle with angle D. I take the big minus the little and divide by 2. 80 and 20 is 100, so 100 minus 50 is 50. Divided by 2 is 25. Angle D is 25. Okay. Here I've got some tangent situations going on. J is going to be half of 100. And E is going to be half of 80. So we've got 50 and 40. Okay. Here I have an inscribed angle for angle A. Angle A is going to be half that, so it's going to be 40. Angle I, another inscribed angle, so it's going to be half of 50, which is 25. We're just isolating each piece that we care about for the moment. So here we have an inscribed angle covering all 90 degrees of that. So we get 45. B, same thing, inscribed angle. Half of 100 is 50. Another inscribed angle looks like we're trying to pull off here. Yes, angle B is 50. Okay, so this is the inscribed angle here. It's covering the 20 and the 80, giving you what you need. And angle R is the straight line opposite of that. So B and R make a straight line. So we have 180 minus 50 gives me angle R being 130 degrees. All right, summarize what you learned about in the lesson of 9.4. Mainly inside, you add them together. Outside, you subtract them. If it's on it, you just divide by 2. Kind of the quick summary. And hope you enjoyed the bonus part. And those were pretty complex problems, but I think we handled them pretty quickly. Isolating bits of information one at a time is how you solve those big problems. And again, those are extra credit on the homework. So if you're looking at 15 and 16 going, it's okay. Just take it one piece at a time if you want the extra credit. Okay, that's all I've got.